Welcome. In this video I will show you how to use the script GeneOccupancy.run. The concatenation of thousands of genes often generates large amounts of missing data. This missing data can be dispersed along the matrix or can be concentrated in some taxa and/or genes. For that reason, in phylogenomics, the data matrices are often filtered before tree searches, restricting the analysis to those taxa or genes that have low levels of missing data. The complement of this is being referred to as occupancy level. It means that a gene that is sampled for most of the species will have a high occupancy level, while a gene that is sampled for just a few species will have a low occupancy level. In this case, the gene with the highest occupancy level is the gene 1, and the gene with the lowest occupancy level is the gene 5. The same concept applies for the occupancy level of the species, now referring to the number of genes that a certain species has in the matrix. Having in mind this background, we wrote a script called GeneOccupancy.run. This script calculates the gene and taxon occupancy level for a given dataset. With this information, the script generates a visual representation of the presence-absence of each gene for each taxon. In addition, the script allows generating subsamples of the datasets with the levels of occupancy saved by the users. This script is very easy to use. As the script has only two optional arguments, the steps for running it are the same for the Gui version and for the console. So I will show you only one example of the use of GeneOccupancy.run. For the example, we will use a dataset from this paper by Jason Comer and colleagues. The dataset has 168 loci and 35 species. The first step is to load the data file. So we need to go to the menu File, Open Input File, and choose the file. If we type the command blocks, we can see here the defined blocks or the defined loci in the alignment. Now I will ask TNT to show me the help of the script typing run GeneOccupancy.run help. Here is the entire information of the script. Here you can see, as I mentioned, that the script only has two optional arguments, species and genes. I just need to copy the usage and modify the settings as I want. So for this example, I will include the species that have information for 75 of the genes or more in the original data matrix. It means that the species with less than 75% of the sample genes will be discarded, and I will use the same percentage for the gene level occupancy. Then the complete command is run GeneOccupancy.run species 75 genes 75. Now I just need to press enter. Now we need to wait, since running the script takes approximately 20 seconds for this dataset, but I have the results here. Here we can compare the original matrix and the filtered matrix. We can observe that the original matrix has these dimensions, while the filtered matrix has these dimensions. Obviously, the filtered matrix is smaller than the original. Now I will show you the graphical output. First, we can observe that the species that has more genes sampled is Atalea speciosa, with almost 96% of the genes sampled, while the species with less genes sampled is Kingia australis, with 61% of the genes sampled. We can also observe that the lowest occupancy level of the blocks is the block 158. And finally, we can observe here that the area defined by the black lines is the area that was included into the filtered matrix. It means this area. The percentages used as limits correspond to the complete matrix. Alternatively, you can run the script in two steps. First, prioritizing one of the occupancy criterion, and then rerun the analysis considering the second criterion on the previous generated matrix. This is the end of this tutorial, and just remember that you can run the script in the console in the same way that we ran it in the Guión version. In addition, you can modify as you want this graphical output using programs as Inkscape or CorelDRAW. You can change the colors, the fonts, etc. Thank you, and see you in the next video.